All right, lesson 9A, we're going to look at confidence intervals for means when we have large sample sizes. All right, so to get an example of what a confidence interval means, we're going to look at Hurricane Katrina, which hit New Orleans in 2005, and people that had not evacuated the city ended up sheltering in the Superdome, which was the football stadium. And it was like very chaotic. People were getting pulled off their roofs and shuttled to the stadium. And so FEMA, which is the federal agency that helps with natural disasters, needed a way to count the number of people in the stadium. And so the best that they could do was take a cluster sample. They picked 10 sections in the stadium, counted the number of people in each of them, and the average number was 137.7. All right, so they know that's not the exact number. It might be a little bit less, it might be a little bit more if we were able to count every single section. All right, but they were just trying to get sort of a range of numbers that would give them a reasonable estimate. All right, and that range is called a confidence interval. So it's the range of numbers that we are some percent, usually it's going to be 90, 95, or 99% confident that it contains the true population mean. All right, and we get that range by adding and subtracting a margin of error to the point estimate. All right, and the point estimate is our sample mean. Okay, so here's our steps. First, find the point estimate. All right, that was our sample mean. That the symbol for that is X bar. All right, then we identify the level of confidence. Like I said, usually it's going to be 90, 95, or 99. And similar to our level of significance in hypothesis testing, the level of confidence will be given to you in the problem. Then we calculate the margin of error. We're going to look at that formula on the next screen. And then we find the interval by taking our point estimate and adding and subtracting the margin of error to get our lower end and higher end of the range. Okay, so formula for margin of error, E equals Z sub C times sigma over the square root of N. All right, Z sub C is the Z-score that is associated with the confidence interval. So whatever confidence interval they give you in the problem, 90, 95, or 99%, these are the Z-scores that go with those percentages. So these three numbers are the ones that you're going to use for Z sub C. So take a picture, screenshot, write this down. Just make sure you have these three numbers because you're going to need them to find margin of error. Okay, sigma, which is this letter, remember that's standard deviation. It might be given to you in the problem, but if not, we're going to find it using 1var stats on your calculator. Now, your calculator will give you two numbers for standard deviation. It will give you sigma x and it will give you sx. All right, sigma x is population standard deviation. If we're using 1var stats on our calculator, we don't have population data. We have sample data, so we need to use sx. So if the number's not given to you in the problem and you're using your calculator, you need to use the one that says sx. Okay, and then n is the sample size. All right, just like it was in our last two chapters. Okay, so let's look at an example. Here we took 40 random users of some social media website and counted the number of friends that they had on that website. And we want a 95% confidence interval for the average number of friends. Okay, so first thing we need is the point estimate, X bar. That's the average number of friends. All right, and the way I want you to do that is I want you to use your calculator and use 1var stats. So we did this earlier in the year. Okay, and if you don't remember, here are the directions for Casio and for a TI. Okay, you need to type all the data in and then follow the directions to get the 1var stats, and that's where we're going to get our point estimate, so our X bar, and our standard deviation. So what I want you to do right now is I want you to pause this video, I want you to grab your calculator, and I want you to type all this stuff into stats and get the X bar, so the point estimate for the mean, and the standard deviation SX for our sample data. So do that right now. All right, so hopefully you were able to get these numbers. So X bar, the average number of friends here would be 130.8, and then the standard deviation SX was 52.6. Okay. Next thing we're going to do is find E. So we're going to find our margin of error. So that formula is Z sub C. All right, and so that's the Z-score associated with our 95% confidence interval. All right, and like I said, I wanted you guys to have this written down. So with 95% confidence interval, that is our Z-score, so 1.96. So my margin of error is going to be Z sub C, which is 1.96, and then I'm going to multiply that by the standard deviation, and we got that from our calculator of 52.6, over the square root of n, and n is here, so that's how many samples did we have, and we had 40 of them. Okay, so now grab your calculator and do this math for the margin of error. Okay, and we're going to round to the nearest hundredth here, so 16.3, and the next number was 0. You don't need to write the 0. So 16.3 is our margin of error. So what we're going to do is take that margin of error, I'm going to subtract it from my point estimate, and I'm going to add it to my point estimate to get the range. So 130.8 minus 16.3 and 130.8 plus 16.3. Okay, and when I do that, the numbers that I get are 114.5 and 147.1. And that's usually how you'll see the answer written for a confidence interval, is it looks like an ordered pair. So we are 95% sure, okay, that the true average number of friends that everybody has on this website is somewhere between 114.5 and 147.1. Okay, and that is how we do confidence intervals when we have large samples, meaning greater than 30 is our N sample size.